Okay, in this video, we are going to learn two techniques for evaluating two different types of limits. In the last video, we encountered the following example. Limit as x approaches -2 of x plus 2 over x squared minus 4. When we plug in -2 for x, we end up getting 0 over 0, which we called an indeterminate form. Reason being is because when you get 0 over 0, that basically says that the answer could really be anything. So you can't determine the answer from getting 0 over 0. So the technique that I'm going to illustrate for this example it's a really simple technique. All we're going to do is factor. All right. So this technique only applies when you have a polynomial over another polynomial, and you get 0 over 0 when you try to plug in what x is approaching. Okay? So in this example, we do have a polynomial over another polynomial. It is giving us a 0 over 0 indeterminate form. Therefore, we are going to try and factor. Okay, so in this example, we can factor our denominator. So x squared minus 4, it's a difference of squares. It's going to factor as x plus 2 times x minus 2. Now what we see is we have x plus 2 in both the numerator and denominator, so we can actually cancel them out. That's going to leave us with 1 over x minus 2. And taking the limit as x approaches -2, what we can now do is just plug in -2 for x. And we're going to get an answer of -1 over 4. Okay. Let's do a similar example. So we have the limit as x approaches 3, x squared minus 7x plus 12 over 4x squared minus 7x minus 15. We have a polynomial over a polynomial. Let's plug in x equals 3 and let's see what that gives us. 3 squared is 9. 7 times 3 is 21. So 3 squared is 9. Times 4 will be 36. 7 times 3 is 21. Okay. If you do the arithmetic, we do get another 0 over 0. So because I have a polynomial over a polynomial and I'm getting 0 over 0, I'm going to try and factor my polynomials now. Now, a good tip when you're doing these types of problems to help you with factoring, we've already seen that x equals 3 makes both the numerator and denominator equal to 0. That means that x minus 3 should be one of the factors in each of these polynomials. So that helps us, we already know one of the factors for each of the polynomials. In the numerator, it looks like the other factor will be x minus 4. And in the denominator, this will have to be 4x to get the 4x squared. And this will have to be plus 5 to get the minus 15 at the end. Okay? So when you're doing these types of problems, you sort of already know what one of the factors of the polynomials will be, and you can use that to help you with factoring. So now we can cancel what they have in common. That leaves us with the limit as x approaches 3, x minus 4 over 4x plus 5. Now we can try to plug in 3 for x once again. And if we do that, we get negative 1 over 17 as an answer, okay? All right, so now I want to illustrate the second technique. It applies to a different type of problem. So here we have the limit as x approaches 5 of the square root of 3x plus 10 minus 5 over x squared minus 3x minus 10. Now, first let's just try plugging in 5 for x. If we do that, we're going to get 3 times 5 is 15, plus 10 is 25, so we got square root of 25, minus 5 over, in the denominator, we're going to get 25 minus 15 minus 10. And here we find that we do get that 0 over 0 indeterminate form. So therefore, we've got to do something to this problem in order to get the actual answer. Now, in this example, I don't have a polynomial over a polynomial, so I'm not going to be able to factor as I did in the previous examples. In particular, I'm not going to be able to factor my numerator that has that square root inside of it. So if you have a limit that has a square root in it, we have a certain technique for dealing with these types of limits. And that technique is to multiply by what we call the conjugate, and I'm going to explain what that is. First, when is this technique applicable? It applies when you have a square root in the limit, and it's giving you a 0 over 0 indeterminate form. Now, what do I mean when I say multiply by the conjugate? Okay. These two expressions, a plus b and a minus b, we call these two expressions conjugates. So they are conjugates of each other. A plus b is the conjugate of a minus b, and vice versa, a minus b is the conjugate of a plus b. And the reason why we care about conjugates comes from what happens when we multiply conjugates with each other. So if I multiply a plus b times a minus b, if you FOIL it out, what you'll find is it gives you a difference of squares, a squared minus b squared. And what's useful for us about this fact is, notice here that both a and b are being squared. So if a or b is a square root of something, then that square root is going to disappear when we multiply by the conjugate, because when we square a and b, any square roots that they had are going to go away. So if a or b is a square root, then the square root will go away when you multiply by the conjugate. So I'm going to illustrate that with this example. We did have a limit with a square root in it, and it is giving us the 0 over 0 indeterminate form. So what I'm going to do is, well, I'm going to copy down my problem first. Okay. So because I have a square root in my numerator, what I want to do is multiply the numerator by its conjugate. So treating the square root as my a and the 5 as my b, the conjugate of a minus b is a plus b. Now I can't just multiply the numerator. In order to make sure that I'm not actually changing my expression, I need to multiply both the numerator and the denominator by the same thing. What's nice about this is when I now multiply these two fractions together, when I multiply a minus b with a plus b, I know it's going to be a squared minus b squared. A has a square root in it, but when I multiply by the conjugate, I get an a squared, which gets rid of that square root. All right? I am going to pick up a square root in my denominator, but we're going to see that that's actually okay. So I'm just going to leave my denominator like this. I'm not going to multiply it out because it's not going to simplify. But let's see what we can do now that we've done all of that. I can simplify the numerator as 3x minus 15. Okay. Now we have a polynomial in the numerator, and we've also got a polynomial in the denominator. So now I'm also going to factor. So this is kind of using a little bit of the first technique as well. In the numerator, we can factor out a 3 from everything. In the denominator, x squared minus 3x minus 10, we can factor out an x minus 5, as well as an x plus 2. Okay. Then we still have this last term, which I'm just going to keep copying. Once we factor, we can cancel out what they have in common. That will just leave us with the limit as x approaches 5 of 3 in the numerator. And then we just have x plus 2 times the square root of 3x plus 10, and then plus 5. Now that we've canceled something from the numerator and denominator, we're going to try and plug in x equals 5. And if we do that, we're going to get 3 over 7 times, this is going to be square root of 25, which is 5. And we've got plus another 5. So it looks like we're going to get an answer of 3 over 70 altogether. All right. So again, this technique that we have of multiplying by the conjugate, you can apply whenever there is a square root in your limit and you're getting the 0 over 0 indeterminate form. So we're going to do one more example of the same type of problem. For the last example, we're going to have the limit as x approaches 2, the square root x squared plus 5x plus 3. Okay, so actually that should be a 2. Okay, minus 2 minus x. That's all going to be over x squared minus 3x plus 2. All right, first, as usual, just try to plug in whatever x is approaching. So we're going to plug in x equals 2. Let's see what that gives us. So under the square root, we're going to get 4 plus 10 plus 2. So it's going to be square root of 16 minus 2, and then plugging in 2 for x, so another minus 2. And the denominator is going to be 4 minus 6 plus 2. And what you'll find is that we do have the 0 over 0 indeterminate form. So because we've got that square root in the numerator and we've got the 0 over 0, we're going to try multiplying by conjugates. Okay, now something that I am going to do then is this minus 2 minus x that we have in the numerator, I'm going to factor the minus sign out from both terms, which would leave me with 2 plus x, all right? And then still over x squared minus 3x plus 2. So the reason why I wanted to factor this minus sign out from the 2 and the x is because I'm trying to multiply by conjugates. So I wanted to have my a and my b. Now I know that I have a minus b in my numerator. The conjugate is a plus b. So I'm going to multiply by a, and then plus, and then b. All right. And again, you can't just multiply the numerator. You do also have to multiply the denominator by the same thing to avoid actually changing your problem. All right. So now when we multiply a minus b with a plus b, we know that the result will be a squared. And so a squared gets rid of that square root, leaving us with x squared plus 5x plus 2. And then it's going to be minus b, which was 2 plus x, all squared. Okay, so a squared minus b squared. In the denominator, we just have the x squared minus 3x plus 2 times all of this. And I'm just going to leave it as the multiplication of these two expressions. I'm not going to FOIL anything out because that's going to be too messy. And I dropped the parentheses around the 2 plus x here because it's not really necessary at this point. So now we want to try to simplify a little bit. In particular, in my numerator, in order to simplify, I'm going to FOIL out this 2 plus x. So it should FOIL out to be x squared plus 4x plus 4. In my denominator, because I know I'm going to want to factor eventually, I'm going to go ahead and factor this polynomial down here. So that polynomial can factor as x minus 2 times x minus 1. And then we still have times this last expression. Okay. In the numerator, we're going to distribute the minus sign and then combine like terms. So we're going to get x squared minus x squared, so they're actually going to cancel out. We're going to get 5x minus 4x, leaving us with 1x. Then we're going to get 2 minus 4, which leaves us with a minus 2. I'm going to copy my denominator. And now we have the x minus 2 in common in the numerator and denominator, so we'll cancel them out. That just leaves us with the limit as x approaches 2 of 1 over x minus 1 and times the square root of x squared plus 5x plus 2 plus 2 plus x. Now that we've canceled something from the numerator and denominator, let's try to plug in x equals 2, and let's see what our answer will be. So we're going to have 1 over, let's see, 2 minus 1 is just 1. Here we're going to get square root of 16 altogether, plus 2, and then plus another 2, because we're plugging in 2 for x. So that's going to leave us with an answer of 1 over 8 altogether. Okay. So that is my last example for this video. I'm going to make just one final comment about my work, how I wrote it out. All right, so let's just focus on the first example, and let's pay attention to exactly how I wrote everything out. So notice at each step, I continue writing the limit. Okay. At the point where I finally plug in a number for x, that's when I drop the limit in front, all right? This is the proper notation that you want to use when you're writing out your solutions. You are going to get points counted off, more than likely, if you don't have the proper notation in your work. So be sure that you're always writing the limit in front as you're simplifying things. Only when you start plugging in a number for x, that's when you can drop the limit sign, okay? So we went through two techniques for evaluating two different types of limits. In the next videos, you are going to continue learning more techniques for evaluating more types of limits. All right, thanks for watching.